and welcome to another episode of Solving Advent of Code in Rust and Try to Learn Rust in Between. I'm Roberto, and we have
Luciano. Hello.
If you never did Advent of Code is a code challenge that is published every year around the Christmas period. We're working toward last year one. There are 24 challenges that you can find on adventofcode.com. We publish all our code in a GitHub repository, and we have a YouTube channel where we publish all the recordings, and you can see all the recordings. You can find a link in the description of the Twitch channel. Last time we were doing the part 2 of exercise 19. Today we will do part 3, and we will hopefully finish him. And what is exercise 19? If just to recap, exercise 19, the main goal is to have a bunch of 3D points given you in bunch. Every bunch is called a scanner. And you have scanners that are not aligned with orientation and rotation and everything else. So you have to take the first scanner, scanner 0, try to take all the other scanners, rotate them in all the possible ways, try to make them fit. And they fit when 12 points match. But remember that the position is not the same, so they can be translated into space. And so you have to find how much they are translated. And going on like this with all the 30 and something scanners that you have provided in the final input. And then you have your cloud of points, and we have to make a computation on top of them. Part 1 is getting the number of points, or total points, and part 2 is computing the Manhattan distance of the scanner points. We can show you how we imagined all of this with a graph. Do you want to share it, Luciano?
Mm-hmm. Yeah, you're on.
Cool. This one. So we start with one scanner with a bunch of points in a 3D space. So then we find another scanner that is rotated to match the existing one. Then we find another scanner that is matching again. And watch out, this is matching scanner 0 and another time scanner 0. Scanner 0 below. But this one is not matching scanner 0. This one is matching or this scanner or this one because it is down and left. So we have to do this on and on and on again until we run out of scanners to place. And in the end, we have our final cloud of points. Cool?
Makes sense to me.
Yeah, in the previous episode, we did all the utility, and we made a couple of tests on top of those utilities to be sure that they are working. The utility is the rotation stuff and the matching between scanners. We used the data that are provided in the README, so we had basically test cases there. Now we have to do the real job of doing this against all the scanners.
With the real input.
With the real input, yeah.
Okay, so let's change screen. We should see my screen now, where we have basically all the code that we wrote last time. We have this lib.rs, which is basically our place to create the solution, but we created the two libraries, as Roberto was saying. Point 3D, which is basically just a point with 3 dimensions and a bunch of utility functions like to sum them or subtract them or to parse them from a string. And then inside scanners, we have this concept of a scanner struct, which has its own position, which is optional because we don't know it straight away. We'll need to figure it out, and this is going to be part of our solution. And then everyone has a vector of point 3D, which are called beacons, and these are all the readings that every scanner is taking, and that we'll need to figure out if they match. We created a bunch of helper functions. For instance, scanners from input allows us to parse an input file, which looks more or less like this. So you have a first scanner and a bunch of points, second scanner and a bunch of points, and so on, more and more scanners. So we can parse all of that and build a vector of different scanners. And then we have all these different utilities. Scanner from raw coordinates, inverse. And then in a scanner, you can move it. You can test all the different rotations. And you can see if it matches another scanner. And then we have all the tests. So now if we want to start solving part 1, what was the ask of part 1? Let's review it in the README. There. Assemble the full map of beacons. How many beacons are there? So basically, we need to count all the unique points, right?
Yeah. So if you obviously a bunch of points will overlap, but we have to count them only once.
Okay, perfect. So where do we start? So we have here our input for part 1. We are creating all the scanners, importing the current input, which is this input file. So what do we do next?
Okay, so next, let's do only part 1 and then do part 2. Then we can generalize and see if we can put some code together. But let's start writing 2 different functions altogether. So we start having scanner 0, that is the first scanner of the vector, that is our no scanner. And we have all the other scanners in the vector that are the scanners that we have to place somewhere.
Yeah.
So we have to initialize a structure with the no scanners and put only scanner 0 there. And then we can keep a scanners vector as the vector of the no scanners.
Okay, do we want to have a set, or does it need to be another kind of structure?
We can keep just 2 lists or 2 vectors or 2 something, one with the done and one with the to do. Yeah, no scanners, perfect.
And this is basically, it's going to be a vec of scanners.
Yes, again, a vector of scanner.
And what we want to do also here is basically, this is both are going to be mutable.
Yes, because we have to remove from one and add to the other one.
So if we do first...
Do we have to remove? Okay, we'll see going on.
If you do pop, is it going to take the first or the last? The last.
In theory, the last. If you don't have pop with a parameter that takes the position, but I don't think you have that in Rust.
Yeah, we can do get 0, and we know we can unwrap, so we know there is something there. And also the other thing that we want to do, because we didn't do that.
First or first? Fist or first?
First, yes. Dot position equal sum of
0,
0.3d.
Yeah.
0, 0, 0.
0, 0, 0. Oh, yes, it's a tuple, it's not.
Can't we do that? It's behind a shared reference. Oh, so we need to do get mute. Okay.
Okay.
Okay, then in known scanners, we can put first scanner, right?
Yes.
And I don't think it's going to be happy about that, is it?
Because it's a reference, it's a scanner. What is it? Well, we can keep a vector of references instead of a vector of scanners. We can.
If we want to have fun with references, okay.
We can always change it later, right?
I will probably clone it, because then I expect at some point we want to do like a for loop. We skip the first one and we use all the others, right?
If you don't want to remove the first one from scanners.
Okay, let's do this. Then, okay, let's do this. Let's do it here. Let's do first scanner equal get. And then we do .clone. And now we can do first scanner position. And now this can take ownership. Perfect. Okay. So we didn't change the actual first scanner from the original input. We only cloned it and then set the position of the copy and put it here in the first scanner. Okay, then we wanted to do we need another vector? No, right?
In Python, I did another vector that was the no scanners, and I put all the other scanners in that one. And again, but this is a matter how we want to go. I mean, we can use scanners as the no scanners. But at that point, we have to remove the first one from the scanners after we move it in no scanners.
Okay, I'm wondering if there is like a split method on vec. Yeah, let's see.
To split a vector in the first and the others.
Split at.
Yeah, and what is doing?
1. And it returns 2 reference of scanners. So at this point we could do let mute. Oh, but we get immutable references, I think. So it doesn't really help us. Yeah, okay, we get slices. So let's leave it as it is. Let's keep it simple. Okay. And if we can optimize later, we will.
Can you remove the first element from scanners now? Because now it is in no scanners.
Yes. Yeah, so we can do the simplest thing. We can just do scanners.remove self usides.
0, 0. You don't have to unwrap. Cool. Okay.
Don't think so. Oh, it
Now-
was returning that item. Okay, so we can do this, I think.
Okay.
And now we got ownership here, so we don't need to clone anymore. Perfect. Okay, that's what we wanted.
Yes, that is exactly what we wanted. Cool. So now we have two nested for loops. The external loop is looping on top of the GNO scanners.
Okay, so let's rename this one known scanners. Right?
No, those are the unknown
Sorry,
scanners.
the unknown.
Okay. And the other one are the GNO. The known. My God, sorry. My English pronunciation is terrible. Guys.
For scanner in known scanner.
GNO scanners, yes.
Okay.
For all the scanners in GNO scanners.
Oh. Okay, let's say K scanner and U scanner.
UK scanner. Hey, watch out for Brexit.
Yep. Okay. At
Now,
this point, what do we want to do?
If K scanner match UK scanner, K
scanner matches
U scanners. Why UK? I like to say UK.
This needs to be a reference.
This is giving you an option.
These matches was giving us an option of a scanner, so we can do
let some
matched.
Yes, it's matched and translated. Yeah.
Okay.
If there is a matched scanner, we have to put the matched scanner in the GNO scanners, and we have to remove it from the unknown scanners.
Okay, here is only complete. So sorry, say again. We need to
add matched scanner to the GNO scanners.
Yes, so known scanners dot push.
And we have ownership on matched scanner because it's created inside the matches function, right? If you remember correctly.
I think so, but the push wants. What does it want? Known scanners. Why does this work? That should work.
Is a mutable vector. We can add the mutable vector.
Borrow moved value known scanners. Oh, because we are iterating over it and we are mutating it. The usual.
We can add when we iterate. No, we can't add while we iterate.
Nope.
Okay, we have to change a little bit the logic. Okay.
We had this problem before. How did we solve it?
Yeah, we always have this problem. We need also a while loop outside of those two nested loops because this is just one iteration. We need outside of those two loops, we need a while there are unknown scanners.
Yeah, that's probably easier. So we can just say while there are known scanners dot is empty, while it's not empty, right?
Unknown scanners must be empty. GNO scanner is growing. Unknown scanner is shrinking.
Okay.
In theory, is shrinking. Then move the 2.4 inside, and then we have to just if we find a scanner, we break.
I'm not following, but okay.
Let's try. Yeah. Now, instead of pushing in line 16, assign GNO scanners to a variable that we can declare later. In the while, we declare a variable just after the while that will contain. This can be a find, to be honest. Well, then we can refactor later. Just after the while, between line 12 and 13. Add a let mutable.
Oh, there, okay.
Let mutable something. Found scanner, found matched scanner. I don't know. Found scanner.
And initially is not initialized.
But something out of those 2.4 loops, it will be initialized, but it could not be. Yeah.
Is this what you're saying?
Yeah, and then we break. We can break the. How do we break 2.4 loops?
Break 2. In some languages, you can do that.
Yeah, in some languages like PHP, I think you can do that.
Okay. If anyone in the chat knows, tell us.
We can initialize found scanner with an on, so it's an optional scanner. Found scanner in line 13. Initialize it.
Yeah, I don't know if it's needed, but let's see. So
initialize that as known. Okay. Now, in line 18, you break just once. And in line between 20 and 21,
20 and 21 there.
You say if found scanner is not known. I don't know how do you check if is something, is some, okay. You break again. Then out of these two for loops, we will have optionally a found scanner that we have to add to the kno scanner. At this point, we can kno scanner push after the for loop on top of kno scanner.
Okay, so after
this is ugly. This is ugly, but we can see how to make it better.
Yeah,
Here we can do kno scanner dot push. At this point, we can do kno scanner dot push of
found scanner
if it is not known. So we have to do if let. Yeah.
Oh yeah, true.
If let some s equal found scanner. At this point, we can push s to kno scanner, but we also have to find a way to remember to remove is original from the unkno scanner. So do you want to iterate
that's a problem.
In line 15, do you want to loop with an enumerate and keep the index of the element we need to remove?
Okay, so here we need to say let mute
remove index
found index
equal -1
or found scanner
index.
And it's a usides, and initially is what?
We use found scanner as flag, so it can be 0.
Exactly. And here what we do is basically, how do we get the index?
You have to enumerate in line 16.
Yeah, we need to do dot iter dot enumerate, and this is going to give us, I don't remember if it's before or after. Let's see. Why it doesn't like that? Okay, I is usides, so found scanner index equal I.
Yeah. Now we can push in line 28 to kno scanner and remove from unkno scanner. This is ugly. We have to find a better way of writing this. Found scanner index. We don't need to make it optional because we use the option on top of the found scanner as flagged. And we loop until we don't remove everything from unkno scanner. We know that the input is going to work because we know that Advent of Code is good with us. After all of this, we should have all the kno scanners. At that point, we have to make a set with all the beacons of all the kno scanners.
Yes.
After the while, we'll go outside of the while. Then we can move coding functions to have a more readable one.
So here what we want to do is a set.
Is a set with all the beacons of all the kno scanners. So we can do a kno scanner map to extract the beacons. Then we can put them together with a fold, and then we can make a set. Then we can make a count.
Okay, so I'm thinking if we can just use known scanners as it is, and just create an hash set of points, right?
Declare a set of points. Start declaring a set of points.
So let points equal hash map.
No, hash set. No, hash set. Why map?
Because you're right.
Point 3D. Point 3D. Cool.
And this one is equal to
kno scanners.
Sorry, let me remove this one. So known scanners dot map.
Because we have to take only the beacons, because every scanner has 2 attributes, but we only care about the beacons.
Yes, so we can use flat map, I think, right? And return scanner s dot beacons.
Okay, what do we have out of what do we have out of that?
Beacons is
a vector of 3 point. Point 3D that adds which doesn't implement the copy trait. Cannot move out of S beacon. Do we have to move it out? I mean, yes,
I think so, because otherwise we are consuming.
We are copying the points.
Can we do clone
every single
On?
beacon.
Okay, that's probably it.
Yeah.
So at this point, we have...
Do you have to retard the length of points? The size of points, sorry, is a set. So it's probably size. No, length.
And of course, here we were expecting to return a U32. Instead, it's a U size. And we'll need to change the test as well or not?
No, because it's a number, so it's inferring the type.
So is that it?
Will it work?
I don't know if anyone in the chat wants to bet if it's going to work or not. Should we just run the test?
Bet is illegal. They are guessing.
Guessing, yes. What do you feel, Robert? Is it going to work?
But I'm just not sure about they put the remover, and no, I'm not sure what to go. I want to see if we go in an infinite loop.
I say it's going to work. You say it's not going to work.
Okay.
Let's try.
It's
Compiling.
Yeah. This machine is faster than the other one.
Oh, infinite loop.
Yep.
Definitely infinite loop.
Yeah, I think so. So now it's not going to work if it is an infinite loop. So why it is an infinite loop? Let's try to think. Okay, we have an external loop that is looping until unknown scanners, while unknown scanner is empty, while not is empty. So in theory, we are removing at every step from unknown scanner, right?
We are only if we find something.
Yeah, but in theory, we hope to always find something. Okay.
I'm just curious if it decreases ever.
Yeah. Okay. You want to run that with just the debug line?
It is decreasing. It's just very slow.
Why is this slow? It was taking 1 second in Python to do all of this.
Okay, then let's just see if it gets
okay, there. Our code. Sorry, I want to check the Python solution because the Python solution was running in like 1 second, and it's impossible that Rust is slower than Python.
I mean, we probably might have done something stupid there.
Yeah, cloning the universe or something like that.
Yeah, but I don't think that Python doesn't clone.
Oh, right? Python is cloning all the time. Everything is an object. Everything is a set. Okay. You have to run this hook. Sorry, in the time it runs, I will try to run again.
Yeah, and also I remember that we even did a few optimizations. Do you remember that you were like lazily computing everything and then returning? And we instead optimized that as soon as we have a match, it's going to return straight away.
We already did that?
Yeah, we did it last time. So I was expecting this to be a little bit faster. I mean, even more so to be faster than Python.
No, in Python it's taking 20 seconds to run. But here we are a little bit more.
Here we are more than 60 seconds already.
Let me check. I think the algorithm is exactly the same. It's just that I'm yielding the rotations. One big difference is that we compute all the rotation. In Python, I'm yielding all the rotations. So at the first match, I stop.
Oh yeah, that's an optimization we wanted to do. Okay, so if this one turns out to be correct, we can try to do that optimization.
Okay, we are almost there.
Yeah, 3, 2, 1.
Oh, correct. Okay. No, okay. Fast. So you were right. It's working. It's just crazy slow. Cool. We can optimize it. I think first optimization in the rotation, where it's doing all the rotation, yielding instead of returning a vector with all the rotations.
Which is not super easy, but thankfully, because we did it in the last exercise, we know how to do it. Right?
We have to add the crate and use the crate,
exactly.
Right?
So this is because in Rust you don't have generators yet. I think that there is work in progress on that front. So basically, while that happens, there is a crate with a macro that we can use that kind of gives us slightly different syntax, but in all essence, it's like a generators thing. So we can copy from here the
dependency.
Was it exercise 18 or 17?
I remember 18, but if it's not in the cargo.
How is that possible?
It's not an pull request that you forgot to merge.
Oh, maybe here I started from another branch.
Yeah, here you started from another branch. Try to, if it is merged in main, rebase main into this branch. Yeah, you can add because the solution is working. It's just slow. Yeah, if it is slower than Python, it's slow.
Okay, so 19. If we check 18, sorry. If we check cargo toml,
Okay, now
generator,
we have the generator.
that's the one we want. And we can go in cargo toml and add this dependency as well. And if we want to get an example, here we add permutator gen. So it looks a little bit ugly, the syntax, but it kind of works. So the idea is that you can do this gn from the generator library, new scoped, and basically this is what you return, and this is basically an iterator at the end of the day, whatever this entire thing is returning.
Yeah.
But then inside this, you have a closure, and inside this closure, you can use this S, which is kind of a scope thing, yield with, and then you can yield specific items.
What is that move that is after the open round brackets?
Yeah, this is basically saying that it takes, I think if there was any variable from the outer context, it will be moved inside.
Okay, is to propagate the scope from outside.
Yeah, I'm not really sure here it was necessary, unless
Because
it's part of the signature, but I'm not sure. It might be part of the signature.
We will copy and paste for the win.
Yeah, so basically we need to copy paste all of this, and then we'll change it a little bit in our scanners.
Rotation, yeah.
What the hell is going on? Why I have helpers 2, input 2, readme 2?
I have no idea.
Okay, something fishy is going on there. It made copies of all these files. iCloud. What? Ooh, I think my iCloud is conflicting with my stuff here. Whatever. Okay, let's remove
Oh my
this.
god, we are going to die.
Yeah, I think I need to disable iCloud. Anyways.
It's syncing back the files from iCloud.
Yeah, and it's probably thinking that there are conflicts and therefore creating, I don't know, whatever.
Yeah, please, iCloud, mind your own business.
Exactly. Cool. So what we want to do scanners.
You added the crate. Yeah, you are in the right function. Yeah, that
these rotations needs to return something else. So let me copy all this stuff here just as a reference. Right. So here what we want to do is rotation must return a generator of what? Must return a generator of scanner, basically, right?
Yeah, it's a generator of scanner, yeah.
So where, okay, what is the first? So here we have scanner, basically, I think.
Why you had to a tuple there? You were turning...
No, because before we had... we were doing a generic permutation thing.
Yeah, I remember. It's turning a tuple. Cool.
Yeah, this example is basically you pass a generic slice of elements, and it will create all the permutations of 2 elements.
Let me try to understand. The apostrophe underline is the inferred lifetime.
Yes, exactly.
The first empty tuple is an empty type that is what you provide to the generator, if I recall.
Yeah. Every time you call .next, if you were calling it manually, you can pass an object inside, a parameter, but we don't do that, so we can just leave it empty.
And the third and the last one is the type that you return, that in our case is just a scanner. Cool.
Exactly. So now we should wrap everything with something like this.
And we take as a parameter a scanner when we create the generator. Where is that? Here is called
it will be. It's just part of the function. Because the function is itself, right?
Yeah, it's taking self then, basically.
Yeah, exactly. So now what we want to do is we should wrap everything into this. This is what we are going to return. So here we do this. I think, do we need a close parenthesis? We need that, yes. And now lots of red. Why is it complaining? What's the error there? Types.
We are not returning anything.
Okay, so I think we'll need to say done at the end.
Yeah.
So here we'll need to say done.
Is a macro. Yeah.
Which is a macro. And does it return? What did we do? No. And then we need to do this yield width.
Okay, so we have to put s.yield width in the place of scanner
front of
push.
Everything. Yeah, exactly.
In place of scanner push.
Good point. So we can just replace all of that with beautiful multi-cursor.
Yeah, I would have done search and replace, but you are right. There can be some other.
I don't know. Maybe search and replace would have been faster. But
no, done.
And we need to remove all the arguments.
Yeah, there. So every time we add, we return a scanner from raw coordinates, whatever.
And we don't need the list of scanners anymore.
No, we don't need the list of scanners. And it's able to access self from inside because there is the move. So because of the move, we are able to access self inside the generator.
Okay, and because a generator is an iterator, this shouldn't change our code on the other side where we are just doing a loop.
Probably we are doing dot iter somewhere, so we have to remove the dot iter, right?
I think iter still exists because it's an iterable more than an iterator, I think.
But we can try to run the test and see if they work because.
So this permutation can go away because we don't need it.
We have tests in this file, right?
Let's test this file. Yes, you're right. So run all the tests. Seems to be green.
Okay.
So now if we run this guy again, how faster is it going to get?
Cargo in the meantime installed everything.
I think so. So what do you think? I say it's still going to take 10 seconds. What do you say?
10? Okay. I will say less than 10.
Okay, let's try.
No, it's not taking less than 10.
It is slightly faster, but it's not that much faster. It's not like 10x faster. It's probably 2x faster.
I'm looking at the Python code. I'm also seeing that in our loop, we do one match, and then we move it from a list to the other one, and then we go and do another match, and we move it, we do another match, and we move it, and so on. In Python, I'm not moving the objects in the list, but I'm just reasoning on top of the indexes of the elements. So I kept the scanners list. Then I have a done and a to-do set of integers. And then I just move the stuff with moving the integers, not really moving the scanners.
Okay.
But this because Python, I can mutate easily the objects. And another optimization, at every loop inside the while, I'm not only doing one of them, but if I find multiple scanners that are matching the existing scanners, I'm doing all of them together.
Right.
So I keep every loop in the while loop, I have a list of scanners that matched instead of only one scanner that matched.
We should be able to do that, right?
Yes, instead of an option, we can keep a vector of scanner that are the found scanner becomes a vector of scanner. If it's empty, it means that we are done, that nothing was matched. Otherwise, we work on the found scanner, adding them to the CNO scanners and removing them from the CNO scanner. So we have to keep an array of indexes and an array of scanner. It's a vector, not an array, sorry.
Okay, so let's try to
still working, but still slow. Okay.
Okay, so found scanners. It's a vector of scanner.
Yeah. And found scanner index is a vector of usize.
Scanner in found scanners.
Yeah.
IDX.
Scanner in IDX, yeah.
I don't know what's the plural. Indices.
Indexes, yeah, but IDX is perfect.
And it starts with back nothing. So what do? We're basically saying that for this guy, but then we don't break, right?
No, we don't break.
Where do you break?
No, you don't break. You do all the loop, and you will find some scanner match, and you will just. We can not even have the found scanner vector. We just keep the indexes. No, we have to keep the scanner. Sorry, we have to keep the scanner because it's translated.
Yeah, it's a new item.
It's a new item translated, and we have to add it. Not okay.
Okay, so here what we want to do is match scanner gets pushed. So found
scanners that push.
This guy. Yeah. And found scanner IDX.
Push I. And you remove the break, and then you remove the 3 lines in line 20. Yeah, there.
So these 3 lines
go away.
But where do we do the check? Oh, yeah. With these ones go away. Here we do the check, right?
Yeah.
Basically, we do 4.
Yeah. For the found scan, we have to.
We need to zip them, I guess.
Also, I don't know if we will find some duplicates. Let's see, without caring about the duplicates. Yeah.
I was doing JavaScript. Found scanners.
.zip found indexes.
.ether.zip.
I always forget the ether.
.ether, I think.
Found scanner say IDX. Oh no. Okay, sorry, you're doing the other stuff.
I put the index first, yes.
Yeah, cool, perfect.
And then what do we do?
The two lines that are there. Yeah. Only with S and I.
S and I.
Now we have to see, because S is a reference.
Exactly.
And I is a reference. But when remove index, why is complaining about?
Because it's a reference. So I want to do this, and it will do a copy. Here we will do a s.clone. It's a bit crappy.
Or into iter.
Or into iter.
In line 27. If we do into iter instead of iter, it's giving us object instead of references.
Fair enough.
No, it's a question.
No, I think that's a good point. And also, so this is giving us scanners. Is this just going to work? Yes, so we can do the same here. And then we have reference. Well, we get ownership of both.
Yeah, but we don't need them anymore because we are doing
perfect. Yeah, good suggestion. I mean, we want to consume them anyway.
Yeah, we have to consume them. And then we go. Now, the problem of this one could be that we find multiple scanners that are matching. This must not impact our solution, to be honest. No, I think this could work. I don't know if it's faster or not.
Yeah, because instinctively this should be slower, right? It's doing more work.
Let's try.
Because it's trying to match everything.
Yeah, but it's shrinking more fastly. It's shrinking
okay, faster. Fair enough.
I don't know. Let's try.
It is. Oh, it's
failing.
Exploding. Why is it exploding? Removal of index 28. Oh, yeah, of course, because every time we remove an index, all the other indices shift.
So we have to remove from the higher to the lowest. So we have to sort found index.
And we need to sort all of them
together. Yeah, in the same consistent way. We can add a tuple of index and scanner and then sort. So instead of having two vectors, can we have a vector of tuple of usize and scanner? Line 16.
Line 16. Yeah, we can do that. We could do. But how is that going to help us? Only for sorting.
Yeah, because then you sort the other way around, but you keep usize as the first element of the tuple, so it will sort by usize.
Fair enough.
Usize, comma, scanner. Yeah. No, we don't need this anymore. When we push a tuple I, comma.
We push, I and
comma. Yeah, that guy. We remove that line. Yes. Then we just loop. We have to sort before. Can you sort while looping out sort?
I'm not sure. Let's see.
It's a vector, so we can sort a vector. We have to do that before.
Can you iter and sort? No.
No, probably you have to sort it before the for.
Okay.
And also found scanner indexes is not existing.
Sorted scanners.
But it's not doing the sort in place.
Oh, actually, yeah.
Found scanner. Dot.
So found scanners dot sort.
Yeah.
Sort by what?
Let's try
that's
sort.
Just gonna work.
Let's try. Worst case is exploding.
It's exploding. Okay, because they are not ordered. Okay, so it makes sense. And if we do sort by, I think
you can't sort by key and giving 0
and then
as key.
S.0. I think that's the way we do that. No?
No, you have to return ordering object. We did this before.
Sort by key.
Key, and the key is 0. Can you provide?
Okay, that's what we want. Yeah. Right? Now, the other thing I want to check is that this is taking a mutable reference to self, so probably it's mutating.
But we have to do that the other way around. We have to sort not increasing, decreasing. So return minus S.0.
Oh, well, we can do here dot reverse.
Oh, yeah.
I think.
Yeah, but we are sorting. The sort already reversed. Why? Okay.
I don't know.
We can try performances later.
Now, why does it like... Oh, because this needs to be into iter.
Into iter? Can you reverse an into iter?
I think so. I think this one just compiles to a loop with reverse indices.
Okay.
Is only special kind of iterators can do that. Only iterators where you have everything already in memory. Which, because this is a vector, is the case.
Yeah.
Okay, so now let's run the test again.
and hope that it's not exploding. And is not fast there.
It did 3 in one go. Now it did 5. So it is, as you said, it is doing more stuff per loop. So maybe the last few ones will get very fast, but it's still quite slow.
We are not hitting the 60 second for sure. So
it's an improvement. Oh, it did
no,
even
it
fail.
failed. Where?
It panicked. Okay, what happened?
Again, removal of index free should be less than len. That is free. So again, we tried to remove something that why? Sorry, it was working. Try to remove the rev and do minus s.0 just to make me happy.
This one?
No, in 26, remove the dot rev.
Oh, so you want to do this?
Yeah, and remove
or multiply it -1 because
I think I don't know if it's.
And you cannot do it because it's a U-site.
Oh. 100 minus that number.
Can we do that? Okay, it's not super happy. There is probably a better way of doing this, but whatever.
And remove the dot rev in line.
And remove the dot rev.
To make him happy, instead of multiplying by -1, you can do 100 minus s0. We know that we are never going above 100 elements. We have 30.
That's true.
Yeah, but you just don't get why at the end it crashed. Yeah, now he's doing more of that.
Oh, and now it's just telling us to do this. That's why I was complaining. It was just a clippy suggestion. Okay, let's see if it crashes. I think it's still gonna crash because I'm quite sure the rev does the same thing.
Yeah, it was just no.
Okay, so we are still messing up our references when we try to delete.
But why? Because we are enumerate on top of the unknown scanner. We are removing from the unknown scanner.
Is it possible that we have repeated items?
Yes, it's possible.
Let's print.
That is possible, but we have repeated items. Yes, you're right. We have repeated items in the found scanner with the same index. So that must be a set by a set. How do you do a set instead of a vector? Can you do in line 16 instead of a vec? Can you do a set?
Sorry, what I want to do is dbg.
Yeah, no, you're right. We have the same I twice.
And let's see when that happens. $23 is appearing multiple times.
Yeah.
So okay, this is a problem because it's gonna shrink the vector faster than it should, right? And then eventually it's gonna try to shrink it more than it can.
If you put a break without changing any other code, if you put a break after line 20.
20, okay.
You put a break after that, just a break there. What is going to happen?
Okay, let me try to understand. Basically, you are only going to be adding one at the time for every known scan. Might be a solution.
Yeah, but on the speed, I'm still worried. Yeah, there it worked on 2 of them, then 4 of them. So there are no duplicates this way. There's not. We still have duplicates. Why?
15 happens twice. Yeah.
Because 2 different GNO scanner match the same unknown scanner. Yes, we have to make that not a vector but a set. If a scanner can go in a set, can a scanner go in a set?
If it's hashable, yes.
We declare it hashable.
It might be expensive to do the hashing, but let's see. Because they are big objects. Every one of them has a few lines of points. Well, should still be reasonably fast. Let's see.
Or we can use an hash map with the key, the integer, and the object at the scanner. This way, if we find the same scanner multiple times, no, this is not working. Kill it.
No, I think we had an advertisement. So for everyone following, sorry, we basically were trying to figure out exactly why
make it faster.
To make it faster, but why we still have duplicates here. And the reason why we have duplicates is because one known scanner can match
more than one. Yeah, more than one no scanner match one no scanner. That makes sense because in the end they are all together. Now it's an infinite loop now, so kill it. It's not
why
going
is
down
an infinite loop? Oh, because it doesn't find the error. Okay, fair enough.
For some reason we messed it up. Let's try this point. Instead of a vector of usize to scanner, an hash map of usize to scanner in line 16.
Fair enough. I understand now what you mean. Hash map of, and import it, please, of usize.
You just have to remove the brackets to scanner. It was enough to remove the wrong brackets.
And we want to do hash map dot new.
Default? No, can you?
Or I think even default will work.
Capital default lowercase. It's not the other way around.
I think you're right. Okay, so what do we do? We do set.
Yeah.
Oh, insert.
Insert. I don't remember.
And
the key
is I.
And the message scanner. Okay.
Okay, so now what do we do?
Now we loop on top of this hash set.
So for this, okay, that's it.
It's already giving us the objects.
Yeah, it gives you a tuple with.
Can we do that by decreasing I to not have the problem of the remove?
Decreasing I, how?
I was a question.
Oh, you mean in reverse order? Yeah, good question.
I in reverse order.
Can we do the rev? Assuming that there is an order in the key, which is not.
There are not sorted, probably, right?
Yeah. Okay, so let's say
sorted keys.
Sorted items. And we do, what do we do? A vec?
A vector of usize to scanner and scanner. Yeah.
And then we do found scanners dot into either. Dot
either collect.
Either or into either dot collect. Is it gonna work? It does. Cool. And then we can do
sorted items. Sorted by key.
And it's S and S dot 0, right? With the -1 thingy, which was
minus open round bracket S0 as E size. Then everything in round bracket, and you put a minus in front of it.
And now sorted items
into iter.
Jesus. Okay, cool.
I don't think it will be very faster.
This is one of the most horrible solutions we have written so far.
Also, it's not working because
no, there was a warning because I imported default without hitting it.
That doesn't exist.
Okay, now I is always unique because it cannot. If it's duplicated, it gets squashed.
Yeah, yeah, exactly. If it's duplicated, there is a big problem somewhere.
So it works and it takes 37 seconds, which is an improvement. Before it was 120, so it's like 4x, but it's still quite slow.
Yeah, okay. Let's do part 2, then we can think about optimizations. Okay, part two basically is taking the scanners once we have the GNOME scanner. So the code is exactly the same because we have to do the match. And then instead of line 34 being the count of the beacons, we have to do the max of the Manhattan distances of the positions.
Okay, so we could put all of that stuff into a function, right?
Go in the README and read what part 2 is asking.
Good question. Good point, sorry.
README
there. Sometimes it's a good idea to appreciate just how big the ocean is. Using the Manhattan distance, how far apart do the scanner get? In the above example, scanner 2 is this, and 3 is this. are the largest Manhattan distance apart. In total, they are this amount. So they are basically summing
the differences, because 1105 minus 92 is 1187.
Right. Okay.
Then minus whatever minus 2380 is 1175, and so on.
Fair enough. Okay, so let's do a quick refactoring. Let's do
let's make that a function.
fn. What do we call it?
Is composing the puzzle, so I don't know. Is the
processed scanners?
Yeah,
processed scanners.
Yeah. Fine.
That takes scanners, which is a vector
of scanner,
and it returns what?
Another vec of scanner,
which is this known scanners, basically.
Yeah, is a vec of scanner, so they will be different scanner, but still scanner.
So we can copy all of this stuff.
Yes, from 13, but also unknown scanner. Why you don't want unknown scanner?
Because here we are doing it from input.
Yeah.
So this will be our.
Yes. No, the last two ones, no.
Right, we just need to return at that point known scanners.
Yeah, the last two are the part-specific code.
And so here unknown scanners is basically scanners.
Or remove it unknown scanners.
Let's rename it like that. Good point.
Only that now we are doing crazy shit.
Doesn't it to be mutable? Mute here, mute. How do you do that? Because it's taking ownership, so it should be mutable. Why it doesn't allow me to do that? Cannot borrow as mutable.
I don't want to borrow, I just want it.
Yeah, we want to take ownership. Yeah. How do you take mutable ownership?
Try to put mute in front of the variable name, or is in front of the...
Oh, okay. That's how you do it. I was putting it here and cool.
No, because that is the type. Somebody Vugaffa. Hello, Vugaffa.
Hey, hello. How are you? Thank you for joining us. Okay, so now that we have this helper function, we can rewrite all this one, which is going to be basically getting rid of all this stuff and saying known let a known scanners equal whatever we call that function, process scanners.
Our memory is incredible.
And here we just want to pass unknown scanner.
Yeah, that will be destroyed by the function.
And this doesn't need to be mutable anymore.
Because we get rid of the ownership in the line.
Right, yeah.
After. So.
And now all of this is still valid, solution one. Yeah. Well, I'm not going to test it because it's going to take forever.
You can run the test, and then we can go on with the part 2 while it runs.
Fair enough.
It takes 30 seconds. We have to find out, it's slower than Python. I don't like this. We have to find a way, and the algorithm is more or less the same.
Yeah, we'll review it later. So what we want to do here is the same stuff here.
Yeah, I just said that the data generator stuff didn't make any better in the end, the solution.
It did speed up like 2x or something like that. But yeah, it's not as much as we expected.
Yeah, I don't get well. Well, we will probably know where we... Okay, later, after we did this.
Okay, so here what we want to do is basically compare every single point with each other, right?
Yeah, so we need a let mutable max distance equal to 0. That will be our return value.
Should we collect all the points first, or doesn't matter?
It doesn't matter. We have to loop on top of all of them. But yeah, collect all the points.
I mean, should we do something like this?
I don't think we can do that in one line.
No, then when we do this, we do the permutation thing.
We don't need the points. We need the positions.
We'll need so we are only comparing the position of the scanners, not the position of the points.
No, the position of the scanner. The scanner has a position attribute. Okay.
So basically, what we want to do is for S in known scanners, right? And for let's say S1 and S2 in known scanners.
Yeah.
If doesn't matter if they are the same, the Manhattan distance is going to be 0.
Oh, no, Manhattan distance will be 0, so yeah. So you can do a let mutable max distance, let mute equal to 0, because it's a valid distance. We return that. So
and this is what we return, max distance. Yeah. And now what we want to do...
The distance between S1 and S2 is... we have to borrow it.
So the distance is let distance
the
equal,
Manhattan distance is the absolute is ABS,
which I think we need to do it like this as a number. So S. So we do like ABS like this.
Okay,
S1 dot
S1 dot position dot
position
zero
zero
minus S2 dot position dot zero.
Yeah.
Cool.
Then
After the ABS plus, and you have to do the same with dot one and dot two. So
S1 dot
copy and paste.
position dot
One
minus S2 dot
S2
position dot
one
ABS.
dot ABS, and for
I don't like copy paste. I know.
you do like you prefer. No, yes. So yes. No, S1 the first one, and S2 the second.
Good catch. I was trying to see if you were paying attention. Now, why does it like it? Point 3D. No field 0 for point 3D. What did we do with point 3D?
They are not public. No, we made them public.
So how do you read them? Are they point 3D, the position? Oh, yeah, because we need to unwrap. Oh, my God.
Oh, because they're optional.
Okay.
Yeah, but we know that when we are here, they are there. Okay. Yeah, don't unwrap them. Because if we arrive at here, it means that we populated all of them.
No, I broke everything. Did I? Or not?
I don't know.
Why doesn't like that? Oh, because when you call unwrap, you are taking ownership. Okay, whatever.
Okay.
Let post1 equal S1 dot
position dot unwrap post2, and then we can do post1.
I don't think I can do this either because those are all references that we keep looping on. So it's going to complain anyway. Cloned.
My God, why must be so hard?
I'm going to clone like there is no tomorrow.
Yeah,
okay, now we can do
post1.0 and
let me remove all the stuff everywhere. Is it?
Pos. You have to call it pos, not s.
Oh, yes, you're right.
Okay,
now why doesn't it clone? Because we didn't derive clone on a point, or what? Give me the error, please.
Silent Z is
not
asking
an
us.
Iterator.
Chat interrupt. Silent Z is asking us, what color scheme are you using?
Oh, you can do question exclamation mark theme in the chat. It should give you the theme. Try that. So we'll see if the integration works. If it doesn't work, I'll check it out.
And Dan was also suggesting sref, but at this point I'm a little bit lost where.
Oh, let's see if
he made exclamation mark team, and I think nothing happened. So
it didn't work. I'm so sad. I thought I had this thing working.
So at least tell us which team are you using.
It said connected. Okay, let's see. Team. What's the current team? Color team. Kanagawa.
And
thank you, Lambisi, for the Lambisic, I guess, for the follow. And it's clone and not cloned. Okay, because clone works on iterators, right?
Then we have to unwrap.
And then we need to unwrap.
Yeah, oh my God. Uglier and uglier code, guys.
Okay, now finally, if
we are teaching with example of what not to do.
Exactly. And if you know how to do it better, let us know.
Yeah. There are ads. Somebody say that there are ads.
Are there ads right now?
Oh, Lanbik let ver 2 is telling that there are ads.
Oh, okay. Sorry about that. I thought we do like a pre-roll of the ads, so new people shouldn't see the ads. But yeah, we'll look into that. Maybe we'll disable the ads entirely if we can. So mark distance equal distance.
Yeah. And now we have to return. Oh, we already returned that. Okay.
And we are returning I32. Does it need to be an I32?
Why? We do apps everywhere.
Yeah, exactly. So this can be U32. Max distance. Wait.
For some reason, distance is E32. in line 53. But we are absing ABS on all of them, and why it is? Oh, I'm fine returning an int32. I'm not strongly religious about it. Yeah, but you have to put RAM bracket around
I
all
don't
those
care.
Yeah, let's return I32, and you can still return the distance.
Oh, distance.
No, I don't know what is that.
And now we can run I32, and that's it.
And the tests are happy because the test is just a
yeah, the
literal
test
number.
doesn't have types. Let's see how long this is going to take.
But it's taking like the other one because the main function that is computing the stick and matches is taking 30 seconds. So I don't think it's taking the same exact amount of time. Now,
by the way, Yambik, if you're looking for Rust, the video game, I think you're in the wrong place because we do Rust, the programming language, which is also cool, I think. But yeah, probably not what you were looking for. Sorry about that.
Oh my God. And if you're looking for welding tutorials, it's the wrong channel again.
Sorry, Robert, what you were saying? This, by the way, Rust is correct.
If you do welding on top of metal that is rusted, this is the wrong channel.
I got that, but before that, what were you trying to say?
Sorry, before that we can go while we wait, but at this point we waited. And go in the matches function.
Okay, so inside the scanner, we have the matches function. This one.
Okay, this one is looping on top. Okay, just stop a moment. For rotated scanner in rotations, and that is the generator in like 133, right?
So this should be lazy.
This should be lazy. Then we do all our stuff, matching. If they are more than 12, we return. No, okay, nothing. We return as soon as we find something.
There is a clone here that we were wondering if it's needed, but this is what is the key there?
It's a point. It's a 3D point.
Okay, so it shouldn't be too expensive to clone. I mean, we are cloning a lot there because it's like it's a 4 in a 4 in a 4.
Yeah, but there are 3 integers. Come on. Can't be that expensive.
Yeah, shouldn't be that slow.
Yes.
And now I have a machine that should be fast enough. So
yeah, luckily you have this machine. With the other one, we would have been still running the tests. How to make it faster?
Yeah, it's crazy that Python is like, what, 20 times faster?
No, it's 24 seconds, so it's
24 seconds. Okay.
It's slightly faster, but still is faster. Why?
Yeah, and I don't think Google Colab is.
No, the machines
crazy
under
good
there.
Machine, right?
No, they are not crazy good machines. They are very basic machines. I mean, my laptop local is faster. When I did the benchmarks, my local laptop was faster. So I'm doing that there only because I can share them with you when we do stuff. At this point, okay. At this point, it would be nice to be able to do the flame graph.
And see where we spend time. Okay.
Yeah. Do something. This code is running, right?
Yeah, tests we can commit. Yes.
You can remove the debug line that is in the loop in the
lib.
Yes, there is a bug in the loop line there. Exactly. You can commit this code and merge the pull request.
Oh, what the hell is readme 3? Wait. There is still crap here. I definitely need to. Oh, come on.
Do you have to escape the space?
I definitely need to disable this crazy.
Yeah, but add manually only the.
You want to I did add them already. That's why.
That is the reason why I never do add all.
Is also because added them and removing them? No.
No, you have to do git remove, git rm. You just did rm, right?
Yeah.
You have to do. It's not in your history, the free rm. Go up in your command history. Like
it's probably faster for me to do this.
I think it was faster to do 3 times the arrow up and writing git in front of it. Your computer, your rules.
Exactly. Okay.
Nice. No.
Working, but very slow, but still slow.
Just very slow, but still slow. Better than before.
Working also part 2. Okay, so we are committing this. Why is it complaining? Oh, because I rebased on master. Okay. So what do we do next?
Now, nice. Merge the pull request. Do you have a pull request for this?
We do gh repo view. We do. So this is a VR.
Mm-hmm. Can you merge it before it's built?
I think so. Let me just make sure we didn't mess up anything. No, only exercise 19, helpers.
And 20. You added the
read me
copy.
tutor.
Yeah. We can get rid of them later. Come on. Git rm. X20. Read me. Yeah, yes, that guy. And there was also another file with the two. Go back to GitHub. There is also benches with the two.
Right.
So do another git rm. Yeah, bench.
Do you want to remove an entire folder, or do I need to do or? Okay,
why you want
it
to
did work.
Because yes, it's the only. Clean up. Thanks, cloud. Yeah. Push.
Cool. So now if we refresh, files should be clean, only exercise 19 and cargo toml, benches, perfect. Now, if we do squash and merge, okay, can I delete the branch?
Yes, we can go back to main, create a new branch, then changing something in the code. You pull, good. Create a new branch for X19 flame chart, or I think we have the flame chart or not. I have not a huge memory of the flame charts. Check out, not secure. Okay.
Now you can see this amazing CLI tree.
Yeah, that blue is quite dark, but yeah.
Because you're not supposed to really see it. Yes.
Yeah, it's magic.
Okay, so now what do we do? A simple change like in the
Yeah,
README?
simple change to the README, not to the README. It must change the code, otherwise it's not running the binary is exactly the same.
Fair enough. So source, I am afraid it's going to start to create other file too. So let's be careful
we don't
about
commit
that.
them. We don't commit them.
Okay, so
change the order of line 26 with 27 in that file.
In this file, 26 with 27. Cool.
Yeah, you just change the order.
Now git commit git status. Let me make sure there aren't new files. No.
Okay.
Okay. Somebody at the door.
Yeah, sorry a moment.
So let's do a new PR.
I thought I muted my microphone. Can you hear me?
Yes. We heard everything. We know your private life now.
Ah, my God. You know my son name. So you made this. Yeah, there is a flame chart. There is a car.
This guy, it might take a while.
Yeah, it's taking. All of this is taking ages. But guys, if you go on the repository, you will find a flame graph. We can try to understand why it is so slow. You can submit pull request to make it faster, guys. Yeah, or not, channel.
I agree, and probably we did more than enough for today.
Yeah, we did 1 hour and something. So yeah, let's keep this branch to make the exercise 19 faster with this pull request. Probably we could also think of a better algorithm. This is quite brute force, to be honest. But again,
yeah, that's fair enough. Yeah,
it is working. So
should we wrap up for today.
So let's wrap up. You can find the recording on YouTube. The link is on Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday, 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description and give us a follow so that you can be notified. Feel free to leave us comments and to open PR if you find a better way to make it faster. Super fine. The repository of code is here. Send the sovraimpressione. Everything is well accepted. Yeah, we are trying to learn Rust, so don't expect our solution to be the cleanest or more idiomatic ones. If you know better ways of doing things, let us know so we can learn. Thank you for the suggestion in the chat and the collaboration. Are we going to raid somebody?
We are raiding the Primagen, which most people will know already. So enjoy that.
Thank you, and see you next time.
Bye.